In this video, we're going to be looking at finding the factored form of a function. I want to start off by looking at a quadratic because this we know how to factor. I would start off this problem by factoring out the greatest common factor, which in this case is 2. Once I have my greatest common factor factored out, then I can continue factoring. And what I want you to focus on is this constant up front here of 2. We really haven't been doing any problems that involve that constant as a factor, but I want you to know that there's always a possibility that we're going to run into problems that do have that constant factor. Now, when we're factoring our polynomials, we can kind of think of this as the same process as factoring a number using factor trees like we did in elementary school. If I know a factor that I can divide, right, 42 divided by 2 is 21, and then I can take 21 and factor that into 3 times 7. So that we're using the same process with polynomials. I'm asked to factor the given polynomial, and I'm told that 2 is a 0. So it's very similar to what I have up here with 2 being a factor of 42. I'm going to divide using synthetic division. Okay, so my quotient here is 3x squared plus 10x minus 8. And I need to try to find other zeros or other factors. And there's a couple of different ways that I could go about doing this. But I think that probably the most straightforward way is for me to go to my graphic calculator. I've already entered my equation into my calculator. And I want to look at my graph or look at my table to see if I can find another 0. And it looks like I have another 0 there at -4. I'm going to look at my table just to be sure. And I can tell that -4 is a 0. So now what I want to do is to use synthetic division with -4 and this quotient that I have here. This quotient is similar to the 21 that I have here in my factor tree. Now going back up to my original problem where I'm told that k equals 2 and k is a 0. So 2 is a 0. That means that x minus 2 is a factor. And I also found that -4 was a 0. That means that x plus 4 is a factor. And then my third factor I found from here. Okay, so when I'm putting this together, I want to double check to be sure that I don't have a constant here that's a factor. So if I were to multiply my first term in each of these parentheses, x times 3x, I get 3x cubed, which is what I'm supposed to have here. So I don't really need a constant for a factor, so this is my answer. Now I can check to see if I've got the right answer by putting the factored form of that equation in y sub 2. And then we're going to look at the tables. And these tables for y1 and y2 are identical, so I know that those two equations have to be equal. So that is the correct factored form of the equation that I started with. Problem 2. Factor f of x into linear factors given that -7 is a 0 of f of x. I'm going to start off by using synthetic division. Okay, once I have used synthetic division with -7, I can go back to my graph or the table and see if there is another 0 that I can easily find. And looking at this graph, you can't really tell, So I'm going to look at the table. I know that I had a 0 at -7, and then it doesn't look like I have another 0 here listed in my table. But what I want you to notice is that from this point 0.35 to the point 1, -48, I'm going from a positive value to a negative value here for the y's. So the only way that I can go from a positive number to a negative number is if I hit 0 somewhere along the way. So I know that there's a 0 in between 0 and 1. And similarly with the point 2, -45, and the point 380. Here my y value is -45, and I'm going up to a positive y value. The only way that I can get from a negative value to a positive value is hitting 0 somewhere along the way. So I know I have a 0 in between 2 and 3 as well. So there's 3 different ways that I can go about finishing the problem from here. One way is to go back to my graph and do second calc to try to estimate those zeros. That's not always the best way because sometimes your calculator rounds and you don't get an exact answer. So my suggestion is to use one of the other 2 methods that we're going to talk about. Now I'm supposed to be factoring this into linear factors. So one way to finish out this problem is to factor. And we're going to factor using the AC method. So multiply A times C, 6 times 5, and I get 30. I'm going to list out factor pairs of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. Now I want to find numbers that multiply to give me 30 and add to give me -17. Right, that's -17 right here. Well, the numbers that I'm going to be using are -2 and -15. They multiply to give me a +30 and they add to give me -17. So I'm taking this -17 and I am basically just rewriting it into -2x minus 15x. From here, I'm going to factor out a greatest common factor from my first 2 terms. So I'll factor out a 2x. Factor out the greatest common factor from my last 2 terms. The greatest common factor is 5, but I'm going to factor out a -5. And that's going to leave me with 3x minus 1. So I have 3x minus 1 in both sets of parentheses. So the 3x minus 1 gets factored out, and that leaves me with 2x minus 5 in my second set of parentheses. Now going back up to my original problem, I'm told that -7 is a 0. That means x plus 7 is a factor. Now when you multiply these 3 factors out, you're going to end up with x times 3x times 2x as your first term, and that's going to be 6x cubed, and that matches what we started with over here at our original problem, 6x cubed, 6x cubed. So I know that I don't need another constant in front of these factors that I have. Now remember I said that there was a couple of different ways that I could have finished out this problem, and factoring was just one of them. What I could have done once I got to this step right here, 6x squared minus 17x plus 5, is set that equal to 0, use the quadratic formula. So I end up getting 1/3 and 5/2 for my zeros. So from there, I can then go back and find the factors that are associated with these zeros of 3x minus 1 and 2x minus 5. And again, I can check to see if I got the right answer by putting both the equation that I'm given and the factored form of the equation into my calculator. Look at the corresponding tables, and they should match up. Problem 3, factor f of x into linear factors given that k is 0. And my k here is 1/2. So if 1/2 is a 0, then that means x minus 1/2 is going to be a factor. So I'm going to start off by using synthetic division with 1/2. So there's my quotient. I'm going to see if I can use my graphing calculator to find another 0. And I can. I have a 0 over here at -5. So I'm going to use synthetic division with -5. So I have 4x plus 6 as a factor. Now, 4x plus 6 can actually be factored. I can factor out a greatest common factor of 2. So that leaves me with 2x plus 3 in my parentheses. So putting all of this together, I'm starting off with a factor of x minus 1/2, and then I have a factor of x plus 5, and then a factor of 2, and then 2x plus 3. I'm going to take this factor of 2 and multiply it by this factor of x minus 1/2. And I notice that when I multiply these three terms together, I get 4x cubed, which is what I'm supposed to have here. And again, I can put the factored form into the calculator as well as my original function and look at the tables to see if they match up. Problem 4. Find the rational zeros of the polynomial function and write in factored form. This problem is different because I'm not given a starting point. I don't know a factor and I don't know a 0. So what I'm going to do is to put my equation into my calculator and graph it. And it looks like I have a 0 at 1 and 2. And then over here toward the left, it looks like my graph crosses in between two numbers, not right on an integer. So I can verify that by looking at my table. I do have a 0 at 1 and 2. And over here, it's going to cross in between -5 and -6. So going back to my table here, I have 1 and 2 as my zeros. So I'm going to write those down. Now I'm going to use synthetic division with 1. So for my quotient, I have 2x squared plus 7x minus 22. And I want to remind you again that I know that if I have a 0 here for my remainder, then this number here is a 0. So from here, what I'm going to do is use 2 for synthetic division. And remember, I'm not going back to my original function. I'm going back to the quotient that I have from my last step. So my quotient is 2x plus 11. So if I wanted to find my 0 from there, set that equal to 0 and solve. And that's -5.5, which is in between -5 and -6. So that's verified from my graph. So there are my zeros, and here are my factors. So there's the factored form of my function. And remember that I got this factor from down here. And if I wanted to, I can go back and double check to see that this is correct by putting this function and this function into my graphing calculator and see if the tables match. Problem 5, I'm asked to find the rational zeros of the polynomial function and write in factored form. So I can find my zeros from my graph or from my table. I think it's a little bit easier to see my zeros from my table. So -7, -6, 5, and 8. So there are my factors. Now, when I multiply all four of these things together, I'm going to get x to the fourth, which is what I'm supposed to have. So my a is 1, so I really don't need that a there. And again, I can go back and verify that this is the correct factored form by putting this equation into y equals y1 and this into y2, and then look at the tables.